Hey friends, welcome to this lecture making graphs using Stata. If you are new to this course, my name is Enoch. I'm a research assistant at the Department of Medical Epidemiology and Biostatistics at Karolinska Institutet. In this lecture, I want to show you how to generate graphs using Stata. You need to have Stata to be able to reproduce the examples. The teaching materials here are based on Alam's teaching in Applied Epidemiology before. Some other resources can also be found below as well. I will start from giving you some bad examples of graphs. It's always nice to learn from other people's mistakes. And I will also talk about the basic elements of making graphs. Also, I'll show you the study map of graphs. Then I will move on to illustrate different graphs, such as histogram, bar chart, scatter plot, etc. Also, I will tell you how to stratify the graphs and also export them. So first here, I'm gonna give you some bad examples. Graph, they can say more than text, for sure. But sometimes, I would say less is more. For this one, it is way too complex. The patterns of the lines make it difficult to see the trends of different lines, sort of loses the function of convey information by showing a graph. Next one, this one is a bit too fancy. It takes time and more effort to find out the corresponding number from this 3D bar chart. Another extreme example here is this is too less information. Even though the caption says something, I kind of think that they should give more info on the data itself. And sometimes there is no right nor wrong. It is just depends on your interest. There are numerous different ways that you can demonstrate the data set, and here's one example to show you that how it was demonstrated. And another example we can learn from, this is a project I'm working on. This graph should show the proportion of Hodgkin lymphoma patients under splenectomy by year. Apparently, something went wrong in this graph below, and actually, a hint I could give you is that something was missed in the code. Could you find it? 3, 2, 1. Sort was missed. If you just sort it and if it works really well, then you will get the proportion of Hodgkin lymphoma patients undergoing splenectomy by year. Now it looks right. Cool. I'm gonna tell you some basics of making graphs. The principles of making graphs, that's first focus on headings. Headings should be self-explanatory and informative enough as well. Usually it goes at the bottom of the graph. Graphs should also be numbered sequentially, and the numbers should be separated from tables. It means that you're supposed to number graph 1, 2, 3 and table 1, 2, 3. And it is okay to copy and paste graphs, figures from the output of your statistical software like Stata, but if it is a table, then you are not permitted to do so. I'm gonna tell you why later in the lecture, in the next lecture actually. I recommend you to use grayscale plus differentiable shapes or colors plus shapes. Imagine what would happen if you only use the color, either gray or color, without using shape. You would know that people sometimes they print out the graphs and in black and white. It would be really tough for them to find out the corresponding color in your legend. Whereas it's much easy if you have some line patterns, different shapes. Alright, the last reminder is your x-axis and y-axis. They should be clearly defined and go with units as well. This is an example from my master thesis. Yay! Let's check the criteria together. The heading, self-explanatory. Yes, informative, yes, we know it's showing a graph the relative difference comparing different follow-up time. Sequential number, yes, this is figure 6. Is it an output from Stata? Yeah, but that's alright. It is okay to directly take the output of a figure from the statistical software. And different shapes, they were used as well. I use round dots plus triangles with blue and green colors. X-axis and Y-axis, they were clearly defined as well. This is a follow-up time as X-axis, relative difference, percentage as Y-axis. And we move a bit more this study map. This study map is quite useful. I found this one in extremepresentation.com. I think they do have quite a bunch of resources that you can take a look. You can find the corresponding graph they suggested you to make. It is great, I have to say that, to think about what kind of graph that you're gonna generate to convey the info of your data before you output something, before you start to do the analysis. Because the same data, they could be demonstrated in different ways. Maybe some of them there is no like the most correct answer, whereas there are some better approaches that you can take. Here, I would just briefly go through some different graphs. Again, the syntax used in this lecture can be found below. You can download the do file and play it on your own. Histogram depicts the distribution of the data, where x-axis is usually a continuous variable. This one is showing the distribution of age of a group of cancer patients. Bar charts, they show the distribution of discrete categorical data. The example here shows the distribution of regions of the patients come from. So you would say that the highest proportion is people from Europe and Central Asia. Scatter plot demonstrates the relationship between two continuous variables. We see the scatter plot of life expectancy and GNP per capita. In the future, you will learn how to construct a model to describe the relationship between two or more variables. Then make a scatter plot first before you make a model. It's good to know like what kind of the relationship you are trying to find out like through a model. Box plot, I'm sure that you learned that in your basic biostatistics. Box plot summarizes the distribution of the data. Line graph functions similarly as scatter plots. Trying to see the relationship, it is quite often to have time as x-axis. It is quite often to have time as x-axis. And this is just some tip that you can use if you want to stratify the data by a certain variable. Then you can use by. And by the way, why did I use one solid line and the other dashed line here? Yeah, this goes back to one of the principles of making graphs. Imagine that you are just using different colors and you can barely see the difference of the lines if you print it out black and white. So I recommend you, again, to emphasize to use different styles, different shapes or patterns of the lines. And another bonus that I would like to teach is that you can learn how to put multiple graphs together. You can install a program called GRC1 Leg 2 in Stata. It is useful. I use it quite often if I want to put different graphs together. I recommend you to people who are interested in this as well. And then the last part is export. A standard way of doing this is graph export plus location and as the file type you want. It could be PDF, graph, EPS, and so on. Another way to do this is just to click the save button at the top left. Here you can see I circle it side of the window. So again, if you use a click function, what you have to do afterwards? Always remember to copy and paste the code generated from the program after you click it and back to the do file. So that would sort of reproduce the analysis and the output that you did. I would like to come back to this study map from extremepresentation.com again. It is always good to think about what you want to find out, the relationship of two variables, or even only just one beforehand, rather than just go blindly to plot something. Take a look at it. The link can be found below. Thank you, and hey-o!